Let's look at a few problems from your book. I'm going to share a tab now. Okay, can you see my screen?
Yes, sir.
Okay, exercise 2.9. Okay, exercise 2.9. Okay, so let's look at problem number 1. It says I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3. What is that?
0.
Okay, because I to the power of a plus a power a four consecutive numbers, exponents of four consecutive exponents. If they are consecutive numbers, then they will add up to 0. Because suppose I power n is divisible by 4, it will start with I, then it will become -1, then minus I, then 1. So those 4, you take any 4, get cancelled out, and you will get 0. We already saw that in the last. Okay. Matangi Sankar. Hi, Matangi. Yeah. Let's look at problem number 2. Problem number 2. Okay. The value of sigma n equal to 1 to 13. I power n plus I power n minus 1. And what is that?
So I'm solving the problem.
Okay. Matangi and Santosh. So please work on it. I power n plus I power n minus 1. Vedant, you've done it?
Yes, sir.
Okay, very good. This is a problem, right? You can see my working board.
Yes, sir.
Yeah. So the problem is sigma 1 to 13 I power n plus I power n minus 1. Let me wait for Santosh and Matangi. Have you done? So we can split it into two problems. Sigma 1 to 13 I power n plus sigma 1 to 13 I power n minus 1. So this one, so you can see that there are 13 terms to be added. So first 12 we can cancel out because any 4 consecutive terms, so it's going to become 0. So what will remain is only I power 13 here. Okay. And here what will remain similarly, this is starting from I to the power of 0 to 12. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 terms. So 0 to 12. So here again 0 to 11 will get cancelled. And what will remain is I to the power of 12. So we can simply rewrite this as I power 13 plus I power 12. And what is I power 13? Again, if you write it in terms of factor out, the 4. Okay, how many multiples of 4 are there? So that, because I power 4 is like I to the power of 12 plus 1, and this is I power 12. So this is I power 12 plus 1 is I power 12 into I power 1. Yeah. And I power 12, any factor of 4, that will be 1. Okay. Any factor of 4, if you take any factors of 4. Okay. So that will be 1. So we can take it out. So it is simply I plus 1. Okay. So it's I plus 1. Is that what you got?
Yes, sir.
Vedant, what did you get? Santosh and Matangi, did you get it also? Did you get it, Matangi and Santosh? Did you understand?
Sir, can you explain one once?
Okay. See, this is so. I instead of explaining the whole thing, which step you did not understand? If you can point it out, I can explain that.
Sir, I power 12 plus 1 plus I power 12.
This do you understand?
Yes, sir. The next step.
Next step is what is creating problem. Okay, this is like I power 12 plus 1 is I power 12 into I power 1, right? Because this is the law of exponents. Okay, I to the power of a plus b is I to the power of a into I to the power of b. So that's what I have written here. I to the power of 12 into I to the power of 1 plus I to the power of 12. And I to the power of any multiple of 4 is equal to 1. And so on. Why? Because if you take the 4 consecutive ones, I into minus 1 into minus I into 1. If you multiply these 4, it will become 1. Okay. That is why. Okay.
Okay.
So if you multiply the 4, you are going to get minus I square. So which is minus of minus 1, which is 1. So therefore, I power 4, I power 8, I power 12, I power 16, they are all going to be 1. So that's why if any I to the power of big number, big value is given, let's say I to the power of 65, you can simply write it as I power 64 plus 1. Okay, 64 plus 1. Therefore, that I power 64 is just 1. So it will become simply I to the power of 1. So any I to the power of huge number, you can simply factor out all the multiples of 4. Okay, and you can take the remainder. So basically, divide by 4, take the remainder. Okay, so it will get you can transform it that way. Okay.
Okay, sir.
Matangi, did you understand?
Yes, sir.
Okay. We saw problem 2. Let's look at problem 3. I think we saw the formula for triangle, area of triangle, right? That you have studied, long ago. The area of a triangle formed by the complex number Z, IZ, Z plus IZ in the Argand's diagram. So can you please do this? Problem number 3. Hi, Pranjal Patil. Good evening. Good evening, Pranjal. Yeah. So you are a bit late. So we already done 2 problems. So you are looking at the third problem. Okay. Please look at the board. Look at the third problem. Z, IZ, Z plus IZ.
Sir, is this 12th standard?
Oh, this is for 12th standard, Santosh. Today it is for 12th standard. Tomorrow will be for 11th standard. Okay. So I'm not sure whether I will be available tomorrow. It may be rescheduled, but please, wait for announcement from Keshav sir. So when the class for 11th class will be.
Okay, sir.
Are you able to do Vedant Pranjal?
Sir, kindly give me any ideas.
The 3 vertices of a triangle are these. Okay, Z, IZ, Z plus IZ. Okay, so you are requested to find its area. So let us take Z equal to X plus IY. Okay, X plus IY. So if suppose that is represented by coordinates X and Y in argand plane. So then put everything, X, IZ, Z plus IZ. So all those in the same format, X and Y format. So then if the coordinates of the triangle will be known from that, and from that we can calculate the area using the area formula that we saw in the last class. If the 3 vertices are given, there is a formula to calculate the area, so we can use that. Okay. So I into X plus IY will be, I am taking Z equal to X plus IY. So IZ will be I into X plus IY, which is IX plus I square Y, which is IX minus Y, because I square is minus 1. Now, yeah, Z plus IZ will be, add the 2. X plus IY plus IX minus Y. So I'm putting X and Y, rather than, real and complex. I'm putting X and Y coordinates. X into 1 plus I plus Y into I minus 1. And I'm taking out x. There are two terms that has got x and y, ix. So x into 1 plus I. Okay. Similarly, I'm taking out y from these two terms, iy and minus y. So I get y into I minus 1. Now we have the coordinates of the triangle. Okay. Coordinate and sorry, x minus y. We can write it in the this we will write it in the form of real and imaginary. X minus y plus I into x plus y. Okay. So x minus y is the real part. So the coordinates will be in terms of the real and imaginary, right? So the real here is x minus y and imaginary here is I into x plus y. Now that we know what is the real and what is the imaginary, okay, the real is this also we should write real first and then imaginary next. Real first, imaginary next. This is the standard way of writing, right? Now you always see that the real is your x coordinate and imaginary is the y coordinate. Actually, here itself we are taken x and y. That is why it is a bit confusing. If you are taking it as a and b, it would have been easier. Okay. So let us do that. Z equal to a plus ib. So I is z equal to in the same way. Okay. You are getting minus y plus ix, right? That is minus b plus ia. Okay, x minus y, that is a minus b plus I into a plus b. So now these are the x coordinates and these are the y coordinates. So now that we know the x and y coordinates, what is the formula for area? Area is half into determinant of 1, 1, 1. Then put all the x coordinates. What are the three x coordinates? A minus b, a minus b. Okay. And what are the y coordinates? B, a plus b.
So could you
Now
tell me this one more?
solve this determinant. Okay.
So how this value came, sir? A is equal to?
Sorry, Vedant, what did you ask? You simplify this determinant, no? That's the next step.
So how this determinant came, sir? I forgot the steps, sir.
Oh, okay.
For the area of triangle,
So see, any complex number can be represented as a point in the arcand plane, right? So this will be a comma b. This z is your one point, which is a comma b is of 1 point. The other point is minus b comma a. So minus b comma a, something like this. I is z. Minus b comma a. And the third point is z plus I is z, which is a minus b plus I into a plus b. Let us say it is somewhere here. We don't know exactly what are the values. So the coordinates are a minus b and a plus b. These are the three coordinates of the triangle. Okay. If the three coordinates of the triangle are known, if the three coordinates are x1 comma y1, x2 comma y2, and x3 comma y3, then area of the triangle that we have seen in the determinant lesson. Okay. So that will be first line you write as 1, 1, 1. And then you write the x1, x2, x3, and y1, y2, y3. Okay. That is the
Yes, sir.
half of, sorry. area is half of this determinant. Okay.
Yes, sir.
So
Yes,
in
sir.
this case, since the coordinates are, a, minus a minus b, etc. ab minus b comma a minus b comma a plus b. So I have written the determinant in that way. So you expand the determinant, so you get it in terms of a and b. Let's see what you get. Okay. Half into. So what is the first term? 1 into 1, I can just leave it. Minus b into a plus b. Minus. So I'm writing the determinant, expanding the determinant. That I assume you know that. Okay. Minus b into a plus b minus a into a minus b. Okay. So this is the first expression. The second expression is minus, because that means second one you have to put minus 1. Okay. It is minus 1 to the power of x plus y. Right? The a plus b. So here in this case, a plus b is the first row and second column. So that means 1 plus 2, 3. So for this term, we have to take minus. Okay, minus. And the minor, what is the minor determinant? Take out this row and this column. So a into a plus b. Minus b into a minus b. Okay. Then plus, what is the third term? Again, this is plus 1. Plus 1 into a square minus b square. That means a square plus b square. A square plus b square, right? This whole thing. So you simplify this. Minus ab, I'm just expanding, okay? Minus b square minus a square plus ab, then minus a square plus ab minus ab plus b square. That will be half into. So here you see that AB and AB get cancelled. So what remains is minus a square minus b square. Okay. That is what is the first term. The second term is minus of. So here also AB and AB get cancelled. So if you simplify, you're getting minus half into minus a square minus b square, again minus a square minus b square plus a square plus b square. So one set will get cancelled. So what you get is minus half into a square plus b square. Okay. But area cannot be negative, right? So the area formula is actually determinant you take and take its modulus. Okay. So if you get it in negative, we can simply take out the negative, because this we know that a square plus b square is a positive quantity. So this clearly it's coming as a negative value. So modulus of this, if you take, equal to half into a square plus b square. And what is the question? The question is the various options are in terms of z. Okay. So mod is z. So in terms of mod z, everywhere you see that it is in terms of mod z. So let us try to convert it into mod z. And so what is mod z? Z equal to a plus ib. So mod z is a square plus b square. So you can simply replace this half into a square plus b square as area equal to half into a square plus b square. So which is same as half into mod z. Sorry. Square mod z is square root of a square plus b square. Okay. So this will be a square plus b square will be mod z squared. So we can put half into a square plus b square equal to half into mod z squared. So is there an option given for that? Half into mod z squared. Option number 1. Okay. Option number 1, half into mod z squared. So everybody followed?
Yes, sir.
Okay. Let's do 1 or 2 more problems. Okay. So to recap. Now look at problem number 4. Please do problem number 4. Okay, the conjugate of a complex number is 1 by I minus 2. Then what is that number? What is the conjugate of a number is 1 by I minus 2. What is that number? This is problem number 4. Okay. So I written the problem here. The conjugate of a complex number is 1 by I minus 2. Then what is the number? Okay. So basically it is given z conjugate equal to 1 by I minus 2. What is z? Vedant has done. Okay. Ranjal, Matangi, Sharmila. If you are able to do, please let me know you are doing. So I will wait. So who are all doing? Raise your hands, please. Who all know how to do and working on it. Ranjal, Matangi or Sharmila. It looks like none of you are you know how to do this. Okay. So the rule here is the conjugate of a conjugate will give you the number itself. Because the number is, let us say, a plus ib, its conjugate is a minus ib, and you take another conjugate, again it will become a plus ib. Conjugate means keep the real part as it is, only change the sign of the imaginary part, right? So if you take another conjugate of conjugate will be the number itself. Okay, so that is the rule we are going to apply. So here you take conjugate on both sides, z conjugate whole conjugate, which is z itself, equal to 1 by I minus 2 conjugate. So you applied conjugate on both sides. So z equal to conjugate of 1 by I minus 2. So what is the next step? We have to use the properties of conjugate. Okay, instead of trying to convert it into proper form and all that. That is one way. 1 by I minus 2 you can convert into a plus ib form. Okay, and then write the conjugate as a minus ib. That is one way. But here we can do it even more easily. Okay, here the rule that we'll use is conjugate of z1 by z2. It is something like that, right? There are two numbers is equal to conjugate of z1 divided by conjugate of z2. Okay. So we have to use this rule. So that means your result will become 1 by I minus 2 the whole conjugate is equal to conjugate of 1 divided by conjugate of I minus 2. It will be somewhat easier to solve this way. Okay. So what is conjugate of 1?
-1.
No. Conjugate of 1 is not -1. Okay. So this is 1 plus I into 0. Okay. So we are going to only change the sign of the imaginary part. Okay. The real will be kept as it is. So it will become 1 minus I0. I0 anyway is 0. So it will still remain 1. So the conjugate of any real number, if only a real value is there, its conjugate is the same. Okay. Okay. And what is conjugate of I minus 2?
I plus 2.
Conjugate of I minus 2?
I plus 2.
I plus 2. Is that I plus 2?
-2 minus I.
It is I plus 2. Raise your hands.
-2 minus I.
Yeah. So you have to look at it carefully. Okay. You have to write it in the proper form. -2 plus I. This way you should write. Then it will become -1 by, sorry, 1 by -2 minus I. That is how you should write. Okay. The imaginary part alone, you should change the sign. The real part, keep it as it is. So that means, so now you can take one -1 as common. Okay. Right? 2 plus I. It will be -1 divided by 2 plus I. -1 divided by 2 plus I. -1 divided by I plus 2. Which option is that? Option number 4. 2. Number -1 divided by I plus 2. Option number 2. Okay.
Option 2.
Option number 2. So everybody got it?
Yes, sir.
Okay. So we'll do one more problem, and then because we have to move on. This problem. You should try to do all the problems yourself. I've been repeating many times. Okay. That is what will give you the confidence and give you the make sure that you remember the formulas or the properties. They're all not complex formulas. They are very simple properties that we need to apply here. Okay. So look at problem number 5. Okay. Is root 3 plus I whole cube into root 3I plus 4 whole square divided by 8 plus 6I the whole square. Okay, that is Z. Okay, so then what is the modulus of this? So you're asked to find the modulus of this complex expression. Okay, root 3 plus I whole cube into 3I plus 4 whole square plus divided by 8 plus 6I whole square. So who are all able to do this? Remember the appropriate property here. Vedant. What about Prajal, Matangi, Shamila? Why don't you all turn on the video so I can see, what you are doing? Are you able to follow? Pranjal, Matangi, Shamila, can you please turn on the videos? At least I can see whether you are there, you are doing something, or you can look at me and ask me what you don't understand. It's a network issue. So you're working on it, right, Shamila? Are you able to do or are you not able to do? Can you speak at least? What about Prajal, Matangi? Why don't you turn on your videos? Sharmila, you are able to do. Okay. Ranjan, I want to make sure that all of you are understanding and are able to do. That's why I'm pointing at you and asking. If you don't know, ask me. There's no point in simply sitting and not responding at all. I don't know what you are doing. So Vedant, have you done it? What answer did you get?
Yes, sir. I have done, sir. So I got 2, sir.
You got 2. What did you get, Shamila? Shamila, could you do? Okay. Let me do it now. Okay. So modulus of a complex expression can be simplified. You don't have to multiply all of these. Okay. It's complex numbers. Take the cube and square and all that. But here you have to use the property of modulus numbers. So modulus of A, B by C is equal to modulus of A into modulus of B. So the first expression can be rewritten in this way. Okay. Do you all agree? Okay. So now modulus of Z cube is equal to modulus of Z cube. Okay, so this is another property because it again follows because modulus of Z cube is same as modulus of Z into Z into Z, which is again modulus of Z into modulus of Z into modulus of Z, right? So that is what we just know. So therefore this becomes modulus of Z whole cube. Like that. So this will be modulus of root 3 plus I cube into modulus of 3I plus 4 square modulus of 8 plus 6I square. Okay. And now it is easy to find out the modulus of each of these numbers. Root 3 plus I, what is the modulus of root 3 plus I? Square root of x square plus y square. Okay. So here x is 3, root 3. Yes, Vedant?
Sir, actually, I'm not feeling well today, so I want to go to hospital, sir, today. So shall I leave the meeting now, sir?
Yeah, that's fine. That's fine, Vedant. That's fine. Okay. So you can,
Sir,
if you're not
sorry
well,
for it.
no problem. No problem.
Yes. Thank you, sir.
Yeah. Now, like I was saying, yeah, the modulus of root 3 plus I, so that we can easily determine. Okay. And that will be square root of root 3 square plus 1 square. The root 3 square is 3, square root of 3 plus 1, square root of 4, which is 2. So I'm writing down modulus of root 3 plus I equal to square root of x square plus y square. So here x is root 3, y is 1. Okay. So this is going to be 2. Okay. So and similarly, what is modulus of 3i plus 4? Square root of 3 square plus 4 square. Okay. So you have to write it as 4 plus 3i. But anyway, it is all the same. 4 square plus 3 square or 3 square plus 4 square. So that's the same. So you have to take x and y, square both and add. Okay. Square root of 16, 9 plus 16, 25. So this is 5. Similarly, modulus of 8 plus 6i. Right? 8 plus 6i. And that will be 64 plus 36 is 100. So square root of 100 is 10. So now you have to simply substitute. Modulus of root 3 plus I whole cube is simply 2 cube. The next term is 3i plus 4. Modulus of 3i plus 4 whole square is 5 square. Whole divided by 10 square. Okay. So it is 2 cube. 2 cube is 8, right? 5 square is 25. 10 square is 100. So you can simplify. So what you get is 2. So Matangi, you are the only one now.
கேக்குதா மாமா நான் பேசுறது
Nama?
கேக்குதா
Clear கேட்கலையேம்மா. Anyway, well, I wanted to do some problems from CBSE also. Okay. So let's do some problems, 1 or 2 problems from CBSE also. Okay. Okay. So look at, can you see the board? There's a problem there, right, Matangi? Okay. So let's do the first problem. Yeah. Let's do the first problem. 5i into minus 3 by 5i. Can you do it and show me what you are getting? May I have a clue? Simply multiply, no? Just multiply them all. It's a simple expression, right? So I've written it on the board. Okay. So what do you get? This 5 and 5 will get cancelled. So if you multiply I and there is a minus, then there is a 3, and I square. Simply multiply them all, that's all. Minus 3i square, right? Do you understand? Plus 3, yeah. Because this is minus 3 into I square is minus 1. That will become plus. Okay. Let's do problem number 3. Okay. Problem number 3. I think problem number similar to problem number 2 we did in the beginning, right? So I want to try another problem. Problem number 3. I power minus 39. Please do that and show me. So what is I power minus 39? Matangi, are you doing? Okay. So what are you getting? So you can tell me. Video irukku undula? If there is video, just turn on the video, Madangi. 1 by 13. FD. T, there is no T. What is T? I power minus 39 தானே கேக்குறோம். Asking for I power minus 39. What is T? One by T cube. One by minus I. What is 1 by minus I? Okay. So how did you do? என்ன formula use பண்ணனே? I explained in the beginning, right? So you have to write this exponent in terms of how many powers of 4 and then the remainder. Okay. I power minus 40 plus 1 in எழுதிக்கலாமா? 39 can be written as minus 39 can be written as minus 40 plus 1, right? That means I to the power of minus 40 can be simply, because its value is 1, I to the power of anything which is multiple of 4 plus or minus whatever. If it is a multiple of 4, it's going to be 1. Therefore, this is simply 1. So it's just I. It's simply I. Okay. If you see something like I power minus 39, you should write it as I power minus 40 plus 1, not like 1 by. Okay. You can write like 1 by also, but it's making it more complex. If you do that, you have to write it as 1 by I power 39, which is 1 by I power 36 plus 3. Okay. So that means 1 by I cube, because 36 is the power of 4, so we can remove. So you have to take like this, you can add 1 by I cube, and 1 by I cube was 1 by minus I. Okay, give minus I. So what is 1 by minus I? So multiply by minus I by minus I by minus 1. Because I square is minus 1. So minus I by minus 1 is I. So you're getting the same answer, but this is much more complex than what wrote in the beginning. Okay, so you simply write it as I power minus 40 plus 1. Okay, so I think we saw problem 3. So look at problem number 4. Can you do problem number 4? Three into 7 plus I7 plus I into 7 plus I7. So to simply multiply each term. So what is 3 into 7? Matangi, are you able to do? So 3 into 7 is 21. 3 into 7i is 21i or i21, whichever way. No? I into 7 is I is 7. I into I7 is I square into 7. So that will be minus 7. I square is minus 1. So it becomes like that. So now take the real values 21 and minus 7. So 21 minus 7, 14. Plus I values, imaginary value. How many are there? I 21 plus I 7. Okay, 14 plus I 28 or 14 plus 28I, whichever way, either way you can write. Because in this problem, they have written in this way I 7 instead of 7I. I have written the answer also in the same way 14 plus I 28. Okay. புரிஞ்சுதா மாதங்கி? Please do problem 7 then. Problem number 7. Or yeah, problem number 7. Let's do. 1 by 3 plus I into 7 by 3. Problem number 7, right? Which is 1 by 3 plus I 7 by 3. Four plus I 1 by 3 minus Can you do this, Matangi? Okay. So all you have to do is take all the new real parts together. So what are all the real parts? 1 by 3 plus 4 minus minus, right? Minus of minus, again it is plus 4 by 3. So put all the real parts together. Then put I into. So what are all the imaginary parts? 7 by 3 plus 1 by 3. Is here? Minus 1. This is minus I. So you take out I, right? So minus 1. Now you have to simply add them and put. Okay, 1 by 3, 4 and 4 by 3 if you add, that will become 1 plus 12, 13 plus 4, 17 by 3. So this 4 will be 12 by 3. Yeah, so 12 and 1, 13 plus 4, 17. Plus I into, here also if you put denominator as 3, this is 7 plus 1 minus 3. 7 plus 1, 8 minus 3 is 5. That's all. 17 by 3 plus I into 5 by 3. Did you follow, Matangi?
Yes.
Okay. Let's do one more problem. I want to do problem number 8. 1 minus I whole to the power of 4. Let's do that. 1 minus I whole to the power of 4. This is problem number 8. Okay. Problem number 8. 1 minus I whole to the power of 4. So do a binomial expansion. What you get is 1 x plus y whole x minus y whole to the power of 4. We have studied binomial theorem in 11th class, right? So use that. Okay. So you can simply expand it. 1 minus 4 into I plus 4c2, which is 6 into I square minus 4 into I cube plus I power 4. So I had given the expansion. Okay. So it is 1. Okay, it is actually a to the power of n minus nc1 into a to the power of n minus 1 into b to the power of 1. That is a binomial expansion. That's what I have written. Okay. Second term is nc2. nc2 is 4c2 is your 6. Okay, that's where the 6 is coming. 6 into I square. 1 to the power of 2 into 2 to the I to the power of 2. So I square. So now write the I square and all will, what is the values for I square, I cube? We can write in terms of I, right? 1 minus 4I, we leave it as it is. 6I square will be minus 6. So I square is minus 1. Okay. So minus 4 into I cube is minus I. So it will become plus 4I. Minus 4 into I cube is minus 4 into minus I. So that is plus 4I. Okay. I to the power of 4 is 1. Okay. I to the power of 4 is. So you see that this 4I and 4I will get cancelled. So what is remaining? 1 minus 6 plus 1, which is minus 4. That is your answer. Okay. Minus 4. Did you follow? Okay. So now look at problem 11. I think it's getting late, getting time to wind up. So we'll close with this problem. Problem number 11. Okay. 4 minus 3I. Find the multiplicative inverse of these complex numbers. 4 minus 3I. Multiplicative inverse of this 4 minus 3I. It's basically same as 1 by 4 minus 3I. So how should we do? We have to multiply numerator and denominator by the conjugate, which is conjugate of denominator is 4 plus 3I, right? So numerator becomes 4 plus 3I and denominator is 4 square minus 9I square. So that means 4 square plus 3 square. Okay. 4 square plus 3 square, which is 16 plus 9, 25. So 4 by 25 plus I into 3 by 25. Okay. Did you follow, ma? Imaginary parts separately.
Yes, sir.
So did you follow this, Matangi? 4 by 25 plus I into 3 by 25.
Yes, sir.
Very good. Very good. Okay. Fine. I wanted to, we'll talk about the polar and Euler forms in the next class. Okay. So I hope we have revised the basics of complex numbers, the conjugate, the modulus,